feature, passing features, freeform feature. So we'll start with the dome feature. This is called a dome. So if you want to get a dome shape from SolidWorks, there are direct tools available. If you don't use the direct tools, you have to draw the shapes and use the revolve tools. So we look at how to get the dome shape directly. So I'm going to use the part file 11.2. This dome tool is not directly available in the command manager. So we have to navigate through the normal drop down list. So if you look at this area, it's not available, and it's a feature, so we have to go through the feature tools, insert feature dome. So the things we are talking today are available here: dome, freeform, deform, indent, flex. All these things are available here. Dome, freeform, deform, indent, flex. These things are available. So we will look at the dome first. So we have to select this face first. So when you select this face, software automatically draws a dome shape which has a height of 10 millimeters. So this is the distance. If I show you the shape it has drawn, this is 10 millimeters from the face to the top uh, point. So we can increase the height like this up to 40 millimeters. So if I press OK, this is my dome shape appearing. Now there are different shapes given in the slides. If you increase the diameter, you can obtain a circular shape. So this is the this is the shape I obtain, and if I increase my height, I will get something like this. So this is a really easy tool compared to the normal revolve tool. Revolve tool, you have to sketch the profile and get the revolve operations done. So here it's not that way. It is easy. So there's an if you change if you want, you can have material removal even. So this is how it can be done. You have to reverse the direction. If you reverse the direction, the dome shape will be going in the other side. So form will form in the other side. You press OK now. There is some material removal happen. So this is a kind of a void. So and there's another way of creating a dome shape without giving the distance. If you have already drawn a point or a sketch, so you can ask the software to create the dome up to that point. So we'll take a part file and show you how it works. Here we don't have a point drawn, so I'll take another part file. figure 11.8. So if I now here you can see a point has been created. This is the 3D point, and they have created a plane, and on top of that plane they have created a 3D point. So and the DOM operation has been done up to that point. So if I just delete this, point is there somewhere on the plane. They have hidden the plane and the point, so we can make it visible. Now this is visible. I'll run the DOM tool now. Insert features, DOM, select the face here. Now I'm going to select this method, the point method, up to this point. The machine is really struggling. Please bear. So if you select the point, it will quickly form. There is a problem with this computer, so that's why it takes a lot of time. Otherwise, if you just select the point and the face, quickly it will be formed. You can observe that. We'll go to the next topic. There is another method called elliptical dome. So the domes we have created up to now is circular shape. So if you want, you can get an elliptical shape dome. For an example, all these are circular shapes. So we can obtain an elliptical shape also, no problem with that. This kind of elliptical dome I can create. So there's another way of creating a dome which uses the direction method. Like extrusions, we use this direction tool. So here in the dome also we have this option available. So it came at last. So this is the uh, dome the dome created with the help of a point. So we will look at the elliptical dome also quickly. Insert features, dome. So if you worry about this much of traveling, you can put the dome tool here. So we have discussed how to do it in the class, how to customize your the face. So here I will select the face here again, and I'll increase the height a little bit. I'm not using the point now. So elliptical dome, if I select elliptical dome, this is the elliptical shape we are getting. So it's different from circular shape. So this can be clearly seen here. This elliptical, this is circular. Next we look at how to use the dome tool with the direction option. So we have discussed this earlier in extrusion tool also. The direction vector can be used to show the dome shape direction. So if you look at this direction and this direction, both are parallel. So an example in this file, software has used this as the reference direction for the shape of the dome. You see it's almost heading towards the same direction. We will see how it works. So this edge is given as the reference direction. So if you delete this edge, you will form a normal dome shape. So give this kind of an edge or a plane to show the direction when you do these kind of examples. So my machine is slow, so just give this direction, will work. Then we look at how to create indents. So the idea of indent is you are going to remove some material. So I'll take this example and show you how it works. Figure 1118. So here, similar to a Boolean cut, they have used this indent tool and remove the material here. So if you just delete this indent, if you suppress it, this is there's an extrusion available. They have hidden it. So I'll unhide it. So this is the these are the two bodies. Why I say two bodies? This is not merged. So when you do this extrusion, you have to make sure that not going to merge with the other body. This unmerged. So as we discussed in the Boolean classes, we can use this combine tool also and remove the material here. Say if you want to subtract this from this body, from this main body, I can remove this. So we continue. So if you apply the Boolean operations, main body is this part, and the bodies to subtract is this part. So you will almost get the same output. But in Boolean operations, there is a small disadvantage. We cannot have a small gap between the main body and the tool body. So if you want to have a gap, you can't use this Boolean operation subtracts Boolean subtract operation. So we will see after this loads. And this is the tool body. Then if I press OK, this is the result. So this is the Boolean subtract operation. So, but we cannot have a gap between the tool body and the main body. So I will show you how to use the indent tool. It's available in insert features, indent. Target body is this one, and the tool body will be this one. And it says there are two options available, either to keep the target body or either to remove the target body. So we need to remove the target body, and it should be a cut. So I will cut it. We will see how it loads. And these are the parameters we can adjust. So we'll show you how to adjust these parameters as well. So I have selected the target body, and the tool body. I have selected all these faces which belongs to the cut, including the bottom face. So those faces are in here. Say if I press if I use the remove selection method, we indent we study different geometry, enter small clearance value. So we do a cut here, so you see how it works. Preview shown. If I press OK, this is my result. You cannot see any difference, but the cutting line forms now. If you to hide this extrude 2, you will see there is a cut. I'll hide this. This is very similar to subtract operation, but here the tool body is not removed automatically. We have to hide it, and we can actually have a gap between the tool body and the cut. So if you want to have that kind of a gap, we'll show you how to do this. Now go to the indent again, indent feature editing. Then there is a tool here to have a clearance. Say if I just give 2 millimeters, you see this is expanding 2 millimeters. It can be inward or outward. So this will helps us to have a clearance between the cutting body and the main body. So I say okay. This is the result. I hope you understood. So this is about cutting. Then there is another nice operations available in the indent tool, which is called as which is not cutting. Actually we are going to change the material of the parent. So if you want to design something like a egg tray, we have to have eggs and we have to have a tray. So we can use the eggs to design this tray hole. So this materials can be formed in such a way that it takes the egg shape correctly, and you can have a clearance also. So I'll show you how this works. It's actually figure 11.21. We have applied some molding methods, so I will just delete them. So if I have created a mold for this tray, so we'll just remove those things. It's not going to be discussed now. So once you remove these things, these molding features, we can see what's inside this tray. Really slow. Just delete this. So this is the outcome we need. So we look at how we can take this. So if you look at these extrusions, these are the this is where they have designed the egg shape. Say all are hidden, eggs are hidden here. So we will just unhide the eggs, unhide the egg, and there's a pattern here, another set of eggs, unhide them also. So eggs are this way, and they have applied this indent tool. So if I just roll back the model, the sweep is just to cover this outer shape, outer. I see they have applied a sweep tool. So we don't need this sweep at the moment. I'll just delete that. So I will delete sweep. This is the situation. So how we can get this shape nicely? Uh, this sketch is for the sweep, so we don't worry about that. We'll just roll back this model and see what's is up. We'll delete this indent first of all, and we'll do it from the beginning. So I will delete this indent. So after I delete this indent, you see this is the full egg. So the material has not been formed. So I'll show you how to form the materials. Now you have to design the tray and you have to design the set of eggs. Then we have to deform this tray shape according to the egg. So we will show you how it works. Go to insert, get features, Indent tool. Target body is this tray, and tool body will be these eggs. So egg can be selected this side or this side. So if you select this side, it should be a remove selection. So I'll just select this side of the egg. You have to select all these eggs. So just select this side. So once you select it, you see if you press cut tool, what will happen? With the gap of 0 millimeters, there will be a big hole forming here. So if I press OK, and hide this egg, and I hide this egg. This is the result. So I don't need this kind of a cut. We will just hide these patterns also. It is slowing down my machine. I'll hide this pattern. I'll suppress this pattern, then it's easy. Then this egg is also a part of the pattern, so we will edit it again. So I'll go to edit, and tool body is this side. So earlier I selected the cut tool. So if you want to form the material, you have to you don't select the cut tool, and here this is the thickness of this material here. So I'll have 5 millimeters, and you can have a gap, say 2 millimeters. So this has a this may have 5 millimeters, this may also have 5 millimeters, and there's a gap between the egg and the actual hole is 2 millimeters. Otherwise you cannot put the egg inside without breaking. So I hope you understood the operation. Now we got this deformation accurately, so we can hide this egg now and see what's the output. This is hidden already, so we'll unhide it. We'll unsuppress this, so you see see how it works. If I hide this egg here, this is how it works. So I hope you understood. We can give a thickness here, we can give a gap between the egg and the hole. So this will allow us to deform materials really quickly depending on the tool body. Then we will skip this one, deform features, for the time being. You can actually do this and see. We have to select these edges and these edges, and if you can form shape like this is like loft feature. And this one also I am not going to talk in this lecture. These are not really useful things. You can click a point and deform your shape like this. So you can just go through these things. So we'll look at this flex feature now. We'll look at flex features. Under flex features we have bending, twisting, tapering, and stretching. So for an example, if I want to draw a bend sheet, uh, we can quickly apply these tools. First we have to select this body, uh, and we can apply a bend. So when you select the body, automatically it will find the middle, and there is a triad, and from this triad also you can rotate and bend the sheet. I'll show you how it works. Select this body, then it will find the exact middle in the sheet. Say if this is 0 degree, this is the normal sheet, and you can change these bending planes. So if you have the planes near to the origin, you can quickly bend the sheet. So now this is not a symmetric bend. This side is shorter, this side is longer, so this side will not get that much of angle like this side. So if I just apply some angle, say -45, this side is bending more than the other side. So you can adjust this bending plane also. Say if I was -0 is here, and if you give say minus 45, depends on the length here, say this is too much. So this is the result. So you can change these plane locations and the triad location also, get different bended sheets in like this. If I just start from the beginning again, select the sheet, and we can change the triad locations. I cannot show everything here since this machine is slow. Change the triad locations, change the trim plane locations manually. You can do it when you get this handle, that curl handle. You can bend it. You can try from your computers and see. Always you can give angles manually from this tool. Next we look at the twisting operations. So the twisting also works in similar manner. You have to select the you have to select the sheet, once you select the sheet, this from this handle I can twist, or you can give angles from here. So you can just do it and see. This is really tough with my computer. I'll give an angle here, so you can see how it twists. Manually also you can do this. 180 degrees one turn, requires 360 degrees double turn. Say press OK. This is your twisted sheet. Then we look at how to apply tapering. So we can change this tapered angle from this tool. So these we can give a distance. Say I'll give a distance 15. This is sorry tapered factor. It's too much. Say 2. We can have something like this, and say 1.5 is my tapered shape. Always you can change these plane locations, triad locations, and do it manually. So this handle is coming from these handles also. I can adjust this tapered factor. So this is minus result, so it will taper the other side. Plus result, it will taper this side. So you can apply different values and see how it works. So these tools are easy. Rather than going to extrusion and editing again, these tools are really quick. So if I roll back the model, this is the model. Tapered model is this. Then we look at how to apply stretching. So you can stretch your models like this without going to detail editing. I'll show you how it works. So this is already stretched. So if I just go to editing and see, this is the original model. So you can see it was stretched from both sides 26.41 millimeters. So if I just press 0, this is the original body. So if I just press 25, this is the stretch body. So this is like we have given some load and the object has been stretched, and if you give say minus value, it will be shrink. So you can give both plus and minus values and see. Always you use the handle availables here, and from these handles you can manually drag and change it. So I hope you understood the flex operations. So we have discussed bending, twisting, tapering and stretching. So next we look at how to position these fastening features in the other section.